All right, the last case we're looking at is called a difference of squares. That's when you have ax squared minus b squared. And then what happens is you end up getting ax minus b times ax plus b. Let's take a look at this in context. This is literally a difference of just two squares. You have 4x squared minus 9. Square root of 4x squared is 2x. Square root of 9 is 3. Now you might be tempted to say, oh, that would just be 2x minus 3 squared. However, as we learned up here, that doesn't necessarily work because when you're squaring subtraction, right, what happens to your last term? You get something positive. So how we compensate for that? We have to eliminate what would be in the middle, that bx that we're typically seeing in the middle. And how do you do that? By having subtraction and addition. Let me show you how this plays out. If I were to multiply this out, right? 2x times 2x gives me 4x squared. 2x times 3 gives me 6x. Okay. Oh, and then negative 3 times 2x gives me negative 6x. Negative 3 times 3 gives me negative 9. Okay. Now if I'm simplifying this, guess what? Positive 6x, negative 6x, they cancel each other out. You get 0. Then you're just left with 4x squared minus 9, a difference of two squares. So this is the other form of a special case, a difference of two squares. So here's another case of it. 25x squared minus 16. 25x, perfect square, negative 16. Well, 16 is a perfect square, not negative 16. And let's see. You get 5x minus 4, because if we solve this out, right? 25x squared plus 20x minus 20x minus 16. So what happens? These cancel out right here in the middle, and you are left with a difference of two squares. You need the addition and the subtraction to cancel out the term in the middle, as well as to give you that final term as a negative. Because you know if you square two negatives, you're going to get a positive. So you need to have a negative and a positive value here. Let's take a look. 3x squared minus 4. Is this a special case? Let's see. Square root of 6x squared would be 6x. Square root of 4 is 2. Let's see. It's a difference of squares. It definitely is. So how can I write this out if I factor it? 6x minus 2 times 6x plus 2. Take a look at our last example here. 16x plus 9. Is this a special case? It is not. It is not a difference of two squares. This is a sum of two squares. Now you might be thinking, okay, well that could just be 4x plus 3. Again, by finding the square root. But if I did 4x plus 3 squared, watch what happens. You get the term in the middle. You do 4x times 4x, you get 16x squared. 4x times 3 gives you, oh, let me fix that, 12x. 3 times 4x gives you 12x. 3 times 3 gives you 9. You haven't canceled anything out in the middle. You can't do that using addition. You need to have two opposite operations. This is not a special case. It certainly is not. However, if we want to change something, we can make it one. If I did 16x squared minus 9, what would that look like when I factor it? Good. Using special cases, 4x 3, 4x minus 3, but you're not done. Remember, you need to cancel out that term that would pop up in the middle, so you need the addition as well. 4x minus 3, 4x plus 3.